Hello, and in this video we will be looking at waves in particle nature of light, specifically for EDEXCEL. We'll take a look at specification point 67 and 68 in this video. So specification point 67 states that we need to know what is meant by a standing/stationary wave and understand how such a wave is formed. We also need to know how to identify nodes and antinodes. And specification point 68 states that we need to be able to use the equation for the speed of a transverse wave on a string, which is root tension over mu. What are standing waves? Basically, standing waves are a vibration of a system in which the same particular points remain fixed while other points vibrate with maximum amplitude. How do standing waves form? Waves traveling in both directions superimpose, producing a series of nodes and antinodes, with nodes being the points of minimum displacement and antinodes being points of maximum displacement. Now we need to move on to look at the equation for the speed of a transverse wave on a string, which is given by root tension over mu, with the tension equaling the mass times the gravitational field strength and mu being the mass per unit length. The units for tension are in newtons and m is the total mass of the masses in kilograms, and mu should have the units kilograms per meter. So having a look at this following question here on the right hand side, we need to show that the units on both sides of the equation are the same. Well, the units for tension are kilogram meters per second squared, and for mu it's kilogram meters per second, and that cancels down to give us meters per second, which is the same as the wave speed units, which is also meters per second. Having a look at this following question here, that says that the diagram shows a wire held under tension by hanging weights at one end and supported by a vibration generator at the other end. The frequency of the vibration generator is slowly increased from 0 until a standing wave is formed. Explain how a standing wave is produced. So basically we have waves traveling in opposite directions, they interfere and they produce a series of nodes and antinodes. Now, the next question states that we need to be able to calculate the wavelength of the standing wave. The wavelength of the standing wave is given by two lots of the length of the original string. The length of the original string in the question is 2 meters, so we need to multiply that by 2. So we end up with a wavelength of 4 meters. And the final question states that the weight is 150 newtons and that the mass per unit length of the wire is 0.005 kilograms per meter. Using the equation given in part A, calculate the speed of the transverse wave along the wire. So we need to substitute in our values. We need to substitute in 150 where the tension is, and we need to substitute in 0.0050 where the mass per unit length is, which is 150 divided by 0.005, and square root all of that, which gives us a velocity of 173 meters per second. Thank you all for watching. I hope this video has cleared up any questions anyone's had about standing waves. Thank you and goodbye.